out. There we go.
Okay, well, welcome to the July 26th, 2022 session of Tangerine SDR and Hamside technical sessions. My name is Dave, KV0S, and this week I've been building an antenna, a little antenna. It's a little disc cone that I've been building with printed parts and 3D printed parts. So that's been an interesting thing. And I've been trying to get some of my radio stuff back up and working. And I'm making slow progress on 2 or 3 fronts, but nothing really to speak of yet. And I consult my friend Dave for technical issues. So anyway, that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. As I said, it's been a busy week. Our GRAPE grant has officially gone to being recommended in the NSF research.gov system. So that's the last step before being officially awarded. So that is very, very good. And then I've been doing a lot of coding for the GRAPE project. So I have this, I'm working on developing this data analysis toolkit in Python. So it looks something like this right now. And I've basically taken some plots that Christina has done, and I've been reworking the backend code. So the neat thing is down here, you can basically put in a date and a time and a node number, and then it loads the raw data. You can just go process data, and it will automatically apply the standard filtering and resampling and all of that. And then it will, and then you can just say grape data dot plot time series. It plots the Doppler shift and the peak voltage, and then it will also, you can do it again. You can say both plot the resampled and the filtered data. It will plot both of those for both Doppler and peak voltage, and also, and it'll convert it to dB. So this is, and it automatically puts in the nighttime period, so you can see the day versus night. And you also have it, you can switch easily. By default, it plots in UTC, but if you give this keyword for solar local time, it will plot in solar mean time. And so I'm working on this. I think I have to go in a second to read a book to Anthony, but it also will produce these nice 2D plots. So it's coming along.
Very good.
I'm going to stop sharing my screen, and I'm going to go read to Anthony, and then I will be back.
Okay.
Okay.
And next on the list is Dan in for XWE. Go ahead, Dan.
Okay, thank you, Dave. Good evening, everybody. Really not doing a lot this week. Had some conversations with AB4EJ about Raspberry Pis, and I'm in the process of trying to compress an image so I can send it to them. And I guess that's about it. Back to you, Dave.
Well, very good. Next on the list is Jules, K2, KGJ. Sorry, I always stumble on that.
That's okay. It's a hard one. Pretty much everybody does on the first time anyway. Not a lot to report this week. I got all of Dave Witten's information on the metadata, and now I've got to integrate it into my ARM 3100 program, and then do the upload to his database. So that's going to be probably a project for this coming week. Other than that, I think I've pretty much finished with my Whisper data on NVIS 80 and 160 tests from my grandson's location near here, 24-hour a day recording. So I have a pretty good pretty good picture of diurnal conditions on 80 and 160 NVIS. So now I've got to reduce all that data and plot it and put it out. Well, back to Net.
Well, fine business. Next on the list is Bill in 8 ET. Go ahead, Bill.
Yeah, today I didn't get too much done. I had a root canal done at noon.
Ooh.
That turned out to be a lot easier than all the stories I'd heard. So it wasn't anything to worry too much about. The rest of the week has been spent trying to figure out the Nano VNA. I've got a pair of them, one that I've had for quite a while, and it started acting up on me. And I couldn't use the PC with it. And so I got another one, brought it home from the radio club, and been struggling with that. So I've learned a whole lot about the internal workings of the display, but I haven't quite figured out how to tell it to jump off and switch from the last measurement to a current measurement. It seems to want to keep the old measurements in there. So there's one thing in the menu that I haven't come up with yet. I'm working on that tonight. So that's about it from here. Back to you, Dave.
Well, fine business. And next on the list is Bill AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to all. Been pretty busy here. We've officially started the beta testing of the Personal Space Weather Station Network Central Control System. We got Nathaniel's great to where it could upload observations made on his magnetometer to the central control system. He had some ideas on some changes he wants to make with the standard. We're kind of doing agile development on it, so that's to be expected. I think what we might end up with. My first shot on this was an observation for, say, for every month, and it would contain 30 files or whatever. But I think probably what we're going to end up with is one observation per day on the magnetometers. Then make it a little bit easier to search for if you just want to analyze a particular day. And also Aidan Monteer, who I'm thinking might be an NJIT graduate now out in Boulder, Colorado, working for NIST, I think. He volunteered that he's got a grape running digital RF rather than FLDigi. So he has volunteered to be a second beta tester. So we're going to work with him on getting the right uploader script working on his grape, which is going to be a little bit awkward because it's in New Jersey and he's in Colorado and his father's going to have to help and this and that, but step by step. Let's see what else. Been working with Dan quite a bit, come up with the next of Ubuntu. I've been running into a series of dead ends on trying to get it.
Bill,
Bill, you're fading out.
your
Your audio
volume
dropped.
just fell off the. Yeah.
There you go.
I'll turn it back to net. The internet here has been in and out a lot, very flaky. But anyway, we've been working with Dan. He's helped out quite a bit. The idea is to get a version of Ubuntu 22.04 long-time support, which will run DRF, GNU radio, and read the Adafruit GPS card. And there's a lot of requirements in there. So been struggling with that a bit, but making slow progress. Also started the paperwork today to go to the COSPAR conference in Portugal in September and represent the NASA team working on the validation of the International Reference Ionosphere. So back to net.
Very good. Busy week. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Not a lot that I'll confess to here this week. I've been plodding along, but really nothing to report.
So
Mhm.
I was going to ask you about metadata.
Metadata. Oh,
for the magnetometers.
yes. I haven't altered the code to generate the metadata the way it should, but I did put but did I not copy you on?
Yes, but
Okay.
other people don't know about it, that we're
Oh,
developing a more complete metadata to help people analyzing the data understand how it was collected.
yes, but nothing grandiose. It's still pretty simple and a simple JSON text file that you either drop into the folder with your other files or actually should get created by the RunMag program or whatever else as soon as, get that part done. I think I've sent that information to others, a few others, but not to everyone. So anyone who feels I have neglected them, please let me know.
I'd like to know what you're planning, because I got to make sure I have a good way to put it in the database. Well, I will enjoy doing that very much, because it's always cool to have metadata with the data.
Okay. I just wasn't, I couldn't remember whether I'd sent it to you already. I'll be happy to copy you on whatever I've sent Jules and Dave. Yeah, it's actually, and I was also responding to Noel's questions, because he's got he's got other magnetometers too, flux gates and stuff, and they have different different ways of acquiring the data. So I wanted it to be possible to do that. So but it's still it's not complex, but I would love to share it. I'll do that.
Oh, okay. You done, Dave?
Yep.
Next on the list, David McGaw, N1 HAC. Go ahead, David.
Good evening, everyone. The big thing this week was tracking down RFI at work. At Dartmouth, we have a number of issues, but it turned out they were unrelated. The one that I've been fighting for a while is our AM broadcast and HF work has some interference coming from a variable frequency drive for an exhaust fan that's up on our roof. And I can't believe this stuff is allowed out the door, but 480 volt high slew rate pulses coming out of this damn thing with no filtering. But I'm in the process of convincing the powers that be that it is the problem, it is a problem, and it's one that needs to be fixed, and how we're going to fix it. So I've at least convinced them that yes, it's a problem. It is the unit that's causing the trouble, and we'll have to find suitable filtering for this device. Should be easy to knock it out, just should be in the box. The other one we thought was the same thing. We have a squib, superconducting junction experiment in one of our student labs, advanced student labs. And they've been having interference problems with them for quite a while. And I thought, oh, well, maybe this is the same thing. Well, we turned the fan on and off, and it didn't make any difference. And then I said, well, how shielded is this? And turns out it's not. And what's been bothering it is cell phones and Wi-Fi. And they thought that they had tried a Faraday shield around it, and then the prof realized, oh, maybe we didn't close the bottom. So we put a better shield on it, and yes, much of the problems went away. And then just to prove it, I took my cell phone, put it on speed test, and put it up next to it. It drove it nuts. So we found the problem there. But it's funny, I'll just say that quickly that they had kept us from having Wi-Fi in the physics building for years because they said, oh, it will interfere with experiments, not realizing that everybody who walks in there, especially as students, is going to have a computer
Why?
and a cell phone banging away on these frequencies.
Yes.
So they finally, a few years ago, maybe 2-3 years ago, finally put Wi-Fi in. But you know, the experimenters still haven't figured out, you've got to shield your experiments.
Yes.
So they're going to make a can for it.
Yes.
So that was the extent of that. And then this following week, I'll actually be going to higher frequencies, a different band. We're going to be, it's the Stellafane Amateur Telescope Makers convention. So we'll be working in terahertz, but that's a big convention that we have it's the Mecca for amateur telescope makers. We get about 1,000 people in Vermont. We become the largest campground in Vermont the weekend of our convention. So it's going to be a nice operation. Second time we've done it after COVID. So looking forward to it.
Say, Dave,
Yeah.
do you have any washing machines on campus?
Not that I know of, at least not in our building.
Okay, and it turns out that variable speed drive washing machines like the
Oh,
top-loading
yes.
Maytag I have are noisy as hell.
Oh,
Oh
interesting.
my goodness.
Yes.
Yeah, we got to convince them to put a computer in these things so that
Yeah.
they know they have to meet FCC. I don't know how these things get slipped through, but they figure, oh, well, it's just industrial. Who
Well,
cares?
And you're in a building with electrical engineers and physicists, so
Right.
Mhm.
they ought to have a clue.
Yeah, this actually is new, relatively new noise because it's a 3-phase drive that runs off of 480 volts. And when I first saw it there, I said, that can't be making noise. There's nothing going on in there. It's just coils and wire. No, not even a commutator in a 3-phase motor. But a couple of years ago, they went through and redid our fume hoods. And this is the exhaust fan for it. And they put in the
Wow.
variable frequency drive.
Oh,
And by the way, guess what? They're overclocking it. It's at 67 hertz, so it's actually overdriving the motor. But
okay. Well, is that it for you?
yeah, I think so. If anyone's interested, it's stellafane.org. You can see what we're up to. It's a very good website and very interesting stuff.
Very good. Next on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and the group. I don't really have much to report. We had out of town visitors this past week, so I haven't done much of anything except entertain. Back to the group.
Okay. Next on the list would be Jay Kennedy. Go ahead, Jay. Turn your microphone on.
That probably did.
There you go.
J6MIO. Slant 4 for the rest of my life, as it turns out. And I was just saying, I appreciate the opportunity to just sit here and listen to the discussion. I appreciate that opportunity very much, and it is a wonderful group that y'all put together, and I support that very much. Thanks so much.
Very good. Thank you. And next on the list would be Jonathan, KC3Y. Go ahead, Jonathan.
Hi, everybody. I had another busy week. On Friday, I went down to Nathaniel's house, and we we installed the GPS splitter. This GPS splitter was, it's an 8-port. The case is machined absolutely beautifully, and it performs really well. I soldered on the power connector, and I soldered on a power cable with those DC DC connectors that amateurs use. I forget the name of them, but that's working well. It's working well with the a new antenna, or the outdoor antenna, and we only connected it to my VLF system. So far with the VLF system, the GPS pulse, the GPS pulse per second has been stable. I have been getting excellent data, excellent timestamp data. So I'm very, very happy about that. There's been a lot of thunderstorms in the area, so local lightning will increase the noise floor and make the filter program a little bit more noisy because the noise floor is higher, but it's been working really, really well. Also, I have been in the process of assembling my my 3-channel VLF system. I'm in the process of soldering the components to the interface board, the gas discharge arresters and the bleeder resistors and the audio isolation transformers and Molex connectors are all soldered in. I soldered in a polarity diode, a Schottky diode for a main power. What I'm going to do is I'm going to have an option this time. You could either use a 24 volt isolated DC to DC converter or a 48 volt one. And I'm going to use SIP sockets. So I just got to order those from DigiKey. I'm still trying to get a hold of another Raspberry Pi 3B, which has not been easy. DigiKey has some that will ship in September, or at least that's what it says right now. Newark has some that will ship in September of 2024. So,
Wow.
so I've been having a lot of trouble there. I'm also in the process of cutting the last pieces of PCB material for my VLF or my H-field receiver. I just have to cut the boards, drill mounting holes, and I could actually start putting the circuit together. Lastly, I spoke with Bill about his grape system with digital RF and the Adafruit GPS module. I talked to him about using GPS daemon or GPSD, which is a low-level program that takes care of the GPS in the background and can provide timing information as well as location information at the same time. So it acts as a low latency NTP peer for either pulse per second or the GPS data. And it will also offer GPS data, timestamp information, and location information over a TCP socket. So Bill and I got got to talking about using GPSD to discipline NTPD, and this will be with the Adafruit board, and a Python program that will pull from GPSD the timestamp and also the location information for his for his use in GNU radio. So once that gets started, I'll start setting up his system and get it working. So that's also kind of exciting too. That's all I have. Back to the net.
Okay. I'm going to pick up Jim, K4BSE. Go ahead, Jim.
Good evening. Sorry I'm late, but I signed on this evening and I had no audio. And I couldn't figure out anything that was keeping me from having received audio. So finally, I just had to go out and restart my computer. And when I came back up, it was working. So one of those mysterious things that happens with computers. As far as this project goes, I haven't done anything new, continuing to collect great data. Seen a fair amount of activity in the ionosphere recently. Seems more than before the we started up on the new solar cycle. But that's about it from here right now. My wife had shoulder replacement surgery, so I've been her chauffeur, and that's getting me out of things a fair amount. Back to net K4BSE.
Okay. And I also wanted, last week I didn't pick up Chong. Chong's here again tonight. Chong, you want to make a comment? Hello? I can't hear you.
How about now?
Now, yes. Go ahead.
I hope everyone's doing well. So I've been finishing the dual configuration. What I got stuck on was, so what the system is doing is that it would save the bootloader in the external flash, but there's some issue that I can't identify why the Neo's processor within the FPGA is failing to boot the image within the bootloader, to boot the bootloader. So there are instances where the FPGA is not giving me the prompt that allows me to reprogram the dual images within the FPGA. So hopefully, somebody will be able to help me with that issue here tonight. That's it for me.
Okay, very good. Glad to see you.
I see you too.
Yeah. Next on the list, let's see, we've hit Jules. Oh, it's Scotty Cowling, WA2 DFI. Go ahead, Scotty.
Well, hello. Can you hear me okay?
Yes.
I'm reluctant to show my video here because of what's going on behind me with all the big, huge piles of junk. So I will, I'll stick with this and give you some video. It's where I want to be, not where I'm at. In a couple of weeks of killer working here, it just almost beat me into the ground getting this house ready for sale, because my realtor's pounding on me constantly saying, it's getting late, the market's slipping, you better get going. And so we've been working 24 hours a day to try to get the place cleaned up. And incidentally, to get a place to where I can work on the Tangerine stuff. And because I know Kong and Nathaniel are chomping at the bit to get real hardware, which I have sitting here, not tested yet, which is going to be tested probably tomorrow or the next day, because I can actually see the bench now, believe it or not. It's getting down to that level. Anyway, see if we can in the after party, see if I can help Kong get his boot going. We'll give it a go and see if maybe I can duplicate it here because I got the same hardware he has. So, but other than that, not a lot going on until this coming week. I think we're going to see a lot of progress. So back over to you, Dave.
So, Scotty, a question. Are you in the new house or are you still in your old house?
No, we're still in the old house. The new house is
Okay.
still dirt.
Oh, okay.
Yeah, well, we're working on the loan, and I tell you what, I've been working on. I don't know if anybody's taken 7 months to get a bank loan or not. But it's just totally absurd. And I mean, they run me around in circles. They ask for the same thing over and over and over again. They have to send it back to the auditor. They have to do this and that. So for instance, they had the construction audit came in, and the guy had a problem. So we proposed a fix to the problem, and we sent it back to him. It took him a week to come back and say, yeah, that'll work. And then we actually implemented it in the figures with the new quote. It takes him a week to sign off on it.
Yeah.
So it's like, it's like it should take 5 seconds to sign off on something that you've already agreed to. But anyway, it's just the story of this whole debacle. I think if I had to do it over again, I just would move somewhere into an existing home. I wouldn't mess with this. Too much of a nuisance.
Okay.
Anyway, back to you.
And next on the list is Tom, N5EG. Go ahead, Tom. Hey, I have a comment for you. I can't hear you on your voice. No. It's usually your sound system volume or something.
He's not muted.
Let's see.
There it is.
Oh, okay, all I did was open the control panel. I didn't actually change the setting.
Something
No.
went to sleep. But I want to tell you, I poked the board, including a couple people here.
Okay.
And we're just about to open up a web page that answers your questions that you asked.
Okay, very good. Yeah, a couple other folks are going and they're looking for the registration link as well. So that's good news. Thanks.
This is about DCC.
Right. Yep. So I think we're all looking for the registration link now, and I know that'll be up soon. So appreciate it. Not much this week related to the project. It's been very quiet, and summer finally hit. It's about 2 months late, but we're definitely in summer now. Back to the group.
Okay. Well, I think that brings us to the end of the list. Have I skipped anyone? Hearing nothing, I'm going to say we're open for general discussion.
Hey, Nathaniel.
Yes.
I have a request for you.
Okay.
I need to give you a phone call tomorrow and talk about some other stuff, but not right here.
Okay.
But what I was thinking of for the Sunday seminar for the DCC was kind of a catch-all for ARDC projects, ARDC funded projects. So I was wondering if you or maybe some of your students would like to talk about the upgrade to your station and all the goodies you're going to get and your new tower and all that stuff, and get everybody all psyched up about getting money for their school radio stations.
Yeah, I can do that.
So I'm thinking we'd have a Sunday thing, and I'm just brainstorming this right here because I haven't talked to anybody yet, but I'm thinking we get either John or Bob to be the moderator and basically have 4 or 5 maybe projects that have been funded by ARDC, and have one or more people come up and talk about those projects for half hour each, something like that, just to kind of give an idea of, look what ARDC is doing here. They're buying a radio station for Scranton. They're funding the Tangerine. And I don't know if maybe Phil is going to be there. He want to talk about the new radome that they got for
Mhm.
odd things, not just like narrow ham radio billboard things,
Yeah.
but all over the map.
Yeah, that sounds good to me. And
Okay.
hopefully we'll actually have made good progress on getting our station going. I'm working right now trying to get the contract put together to actually install the towers and things like that, and trying to get the contract for the engineering firm put together. And it's coming, but I think like your house, it's taking longer than you want it to.
But even if you had like some under construction or some, something, even if you just go take a catalog picture of a 7610 and
Yeah.
saying this is what we're going to get kind of thing.
Yes. Yeah, I have a presentation that's close. It's close to what it's to that already. So it shouldn't be too hard to put together.
Okay.
Yeah.
So
Yeah.
yeah, and I don't know, this is I guess this will be public information, or it will be eventually. Maybe I'm not sure if it's appropriate to talk about it here, but I will anyway, since I don't care. The another party has applied for an ARDC grant to build an SDR-based test instrument. And it looks like it's going to be really interesting. And I really don't want to release the details yet because they haven't gotten the grant yet. But if their grant comes through, I really want to have them present something at DCC, because it's going to be of interest to everyone here and a lot of general use hams as well. So just whet your appetite a little for DCC. And Dave, did you mention we are going to stream it?
Yes, we are going to stream it, but not through Zoom. We're going to just have a YouTube feed because of the bandwidth of the hotel.
Yeah, and so we're dealing with questions. Maybe there'll be a Q&A, maybe there won't. Probably there's a back channel on YouTube. And Dave, I think we get access to that, don't we? When streaming?
Yes, we
So
do.
We'll have some moderators watching there and asking the questions for you, and you'll be able to hear the answers then. That's the plan anyway. Did I get
That sounds
right?
really good.
That's the way we'll do it, right? The way we're.
Yep.
That sounds good to me.
And I'm looking forward to having your students maybe being moderators if they're interested.
Yeah, I'm sure they would be. So I have to start talking to them about, I guess, travel logistics and things like that. Can we do something where, I like having the students and even myself give either 20-minute or half-hour, 20-minute presentations to half-hour presentations. Can we get a few like 1-hour time blocks and split them up between, my students?
Yeah, I think so. Because I know at the ham side, we have some engineering stuff. So at the engineering one, we should have some ham side stuff. And I think in years past, we've done that where we have some people talk about that and give them some time slots. Steve will be coordinating that and getting the schedule all together. Steve Bible.
Okay.
So he's the one
So
to talk
I need
about that.
I need to email Steve.
And get in. I mean, I won't say it's filling up, but sometimes we go begging and we're beating the bushes for presentations, and other times we get plenty and we have to kind of juggle.
Okay. So what situation are you in right now?
I don't think we have anything because we're behind we're late here. We should have a web page open already. I think Dave, the call has gone out from ARL for papers, but
yes. And the links for the hotel reservations are available, but the actual reservation for the meeting is being discussed as we speak.
Yeah. So it's going to go up momentarily here. I talked to Steve today about it, and we were talking about how we got to get this thing going because it's only like 8 weeks away, so we got to have a place, and people are asking, where do I register?
Yeah.
Yes.
We want to get them while they're interested and not have them forget.
Definitely.
Yeah, and the hotel rates is $99, which is a really smoking rate for Charlotte for any place nowadays.
Yeah.
To help make up for the $5 a gallon gas you'll have to spend to drive your car there.
Yeah. That sounds good. So I'll work on trying to organize my students to figure out who is going and who's going to be talking and things like that. So,
Okay,
yeah,
sounds great.
I have a feeling that they're probably going to want to go. Is that right, Kung?
I would love to go. Yes.
Yeah. 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 Kung is dying to go.
Yeah.
So.
And,
That's right.
you know,
Yeah.
this year, I don't think we're going to have funds to subsidize travel, but we can certainly subsidize fee entries. If we have to talk about that at the board, Dave. But
Yes.
I'm all for giving students a extremely rate down to maybe nothing.
Okay.
So
And I can certainly pay for my students' travel, so that's not a problem.
okay, so that would be cool to do that. And I don't know if you heard, we actually got an ARDC grant to help us. It's a sponsorship actually to help to make sure that we break even.
I've heard.
My big concern was that with COVID and with travel, it's so expensive and everything, people might not come. They might just want to listen to the stream. And
Right.
suppose we end up with like 30 people to show up, then we're really in trouble because of the cost of the live venue is really high. So they've agreed to help us out there and buffer us. So the money's there if we need it, and if we don't need it, then we're all good and should take away a lot of the stress of wondering whether we're going to bankrupt the organization with one event or not.
That's kind of how I've done it with the NSF grants for the Hamsci workshop. I would basically write a workshop grant from the NSF, and that would cover all of our basic bills. And then, anyone else who wants to come on top of that, then we're not worried about being in the red.
Yeah. Well, this is really nice of them because we will give back the money we don't use, which is fine because we don't really we don't want them to bankroll us. We want them to just keep our risk low. Is right. What we want. And they came back really fast and are really agreeable. So I'm really appreciative of that. And that's kind of why I'm thinking the Sunday seminar would be a great, we could get a whole variety of projects and show people that this is what's going on with grant money. And I think
we're gonna have a few. Veronica won a $25,000 ARDC scholarship, so she can say something there.
Yes.
So and she's not the only scholarship winner, ARDC scholarship winner, but she's
the more you look around, the more of them there are, more things there are that ARDC.
Right. Yeah,
Scotty,
it's fantastic.
Scotty, I sent you a direct message about that. It's in the chat.
So I guess I meant put this in the chat, but I'm a little concerned. My looks like my magnetometer quit here. And so I guess I need to troubleshoot why it's not working.
Have you done the advice you've already gotten, which was restart it?
Yes, I restarted it multiple times.
Okay.
Be sure you check out the local end. Don't just assume it's the magnetometer itself. Be sure and check out the local end carefully too, because that's really where I suspect my problem is.
Is it seeing the remote temperature sensor?
Yeah,
that's a good question.
Because you show it not having seen the magnetometer unit
is there
itself.
an easy command? How do I check that easily with the run mag program?
Yeah, run mag will do that, and it should show the temperature, not the mag.
Or just do
an I2C detect.
Yeah, I2C detect -Y space -R 1, I think.
Like that.
I don't
Should
see.
be just -Y-1. I
We
think.
see your background.
Oh, that's not very helpful. All right. How about now?
It was a nice picture, Nathaniel.
Thank you.
I think R1, yeah, -R1.
Okay. R1.
Yeah. No, at once, maybe I'm wrong.
I think it's just -1, -Y-1.
No. -R space 1.
That could be, yeah, dash. How about dash?
Yeah, there you go.
There you
Okay,
go.
there you, yeah.
Your bus isn't shorted, but it's not much showing
Not
up.
seeing anything.
No. So nobody's talking, and you should, let's see, do you have a temperature sensor at the local end?
I guess so. I don't know.
If yours
Yeah.
does, you should be
Are you-
seeing it. And
Which
that's
board are
kind of
you
what,
using, Nathaniel?
that's what
What's-
mine's been doing, I believe. And so I don't see the local end.
You should see 3 devices normally, a local temperature, a remote temperature, and a remote magnetometer.
Yeah, and if you just see
Okay.
the local one, it suggests that the local end is working, but you have something from the cable on. On the other
Right.
hand, if you see
Nothing.
nothing, it suggests that something else is going on.
Okay.
And I'm sure you'd rather have it be local than remote.
Oh, much rather.
Nathaniel, I would try an extra magnetometer board
Yeah.
on the Raspberry Pi, and that should hopefully fix that problem.
I
Because
don't
yeah,
know.
it should show the local temperature, and it's not.
Yeah.
So that's why the first thing you should probably do is try the local, or the local board first.
Scotty, do you have a new board you can send me?
Yeah, actually I do. It
Okay.
doesn't have a local temperature sensor on it though, because we deleted those.
Okay.
So that's not going to help you much to debug it.
You bug it, but
I may have a Rev D around that's a reply. I think you have Rev Ds, right? From Tapper.
I might. Yeah. Is this? I do have one other one that's a previous revision of this. Could I? Should that work?
That should
It
work.
should work.
Yeah.
Just plug it into the Pi and don't plug the RJ45 cable in at all.
Okay. Let
Just
me
see if you can read
run to
local.
my garage really quickly. I think I know where it is, but I'll be right back. Okay.
Yeah, but just test the board itself first without, as Scotty said, without plugging in the remote.
There,
Okay.
yeah, there should be 2 in your garage.
Yeah. I think in that box, right?
Yeah,
That magic box.
I remember seeing 2 boards.
Yeah.
Um,
Yeah. All right. Give me a minute. I'll be back so you can
All
keep
right.
chatting.
So Kung, how are you? Are you stuck on the boot problem?
Well, I actually figured it out like right before this meeting, but let me show you some cartoon that Dr. Fizell showed me recently. Can you see my screen right now?
Yep. Mhm.
Yes.
Can you see this picture?
The sphere of death. I like it.
Yes.
Yeah, so everything was working very smoothly this afternoon, but now it's not anymore.
This is a corollary of Murphy's Law, isn't it?
Uh-huh.
Like the law of selective gravitation, that a tool dropped on the workbench will land in the place that it can do the most damage.
Yes.
I can show you, let's see. Oh, let me do a new share. There it is. What are you seeing on your end right now?
I see a nice big tangerine picture in slashes and stars.
That's
Yeah,
right.
what's-
Yeah. So
Is this what you're trying to put up on this? Where
so
are you
this
trying
is
to?
right here. This is just a test for me to see that the board is loading one of my own image instead of the example one.
Okay,
that-
and this is
that
just
they
going to a
provided.
serial port, right?
This is going through, yes, this is going through UART.
Okay,
Is that what we want to use for the official version of the board?
I think so, yeah. I mean, that's a good console port.
Okay.
What would be
Uh,
cool is when I send you this adapter board, it's got an LCD on it. So if you could put a Tangerine picture up on the LCD, that would be an awesome display of it's like a 64 by 64 color OLED display.
that'd be cool. Yeah, this is just an ASCII image that I converted using some online tool. And I do have a question about the hardware. Will there be an external flash on the board?
Yes,
Okay.
big one,
Oh,
512 meg.
oh,
or
okay,
bigger.
okay. So
Yeah.
Kong, I'm using the USB interface on the development board to download and run my NEOS programs. That's one of
That
the,
looks like, Tom, that looks like a serial port, right, to the computer?
yes, but there's a port marked UART, which is not the one to use. And there's a port with an identical connector marked USB, which is the one that you should use.
Okay, so the UART one, what, just goes to a couple pins on the FPGA and you have to write your own?
yeah, I think that goes to the two specified pins.
Yeah, because I
Yeah.
think one of them was a JTAG UART and the other one was you have to instantiate a UART and hook it up to those pins.
Yeah, that's right. Yeah, I'm aware of that. Let me see.
So Tom, to talk to that UART, did you have to instantiate anything special like the JTAG UART?
No, the USB, the NEOS and Porta software automatically downloads on the USB. I think it's through JTAG into the part.
Okay.
And so that's automatic with the tool when you bring up the programmer.
Because I know this board has a USB blaster circuit, has USB blaster circuitry on it, which is
Right. So if you use the development board has the USB blaster function built into it, and there's a connector called USB. So if you connect that to the USB connector on the computer, when you bring up the programmer, it automatically uses that blaster JTAG interface to program everything.
That's right. I'm trying
So that's how I brought up the NEOS code.
okay.
Let me try to program into the system the images, the example images. So
Do you have two separate images so you can identify one from the other?
that's right. Yeah. So one of them has a set of a different set of LED configurations.
Okay. Yeah, I think you said that one of them alternates and one of them flashes or something.
So something similar to that. Yes. Let's see. So I have another question about the design of the system. So is what we want in the external flash, the bootloader, and then we have two images, like a safety one and like an application image one.
Right.
And then is the application image the NEO software for that image? Do we want to have that in the user flash memory or also in the external flash?
It depends if it'll fit in the user flash. It's desirable to have it in the user flash if you can do that. And I think the bootloader should do that. It should run on internal flash if you can make it do that, if it's not too big. When you start adding a bunch of library functions, then the NEOS code gets big and it might end up being too big for the onboard flash.
Oh, okay. Because what I've been trying to do so far is having two of the same NEO software in the external flash. So
And you can do it either way. It doesn't matter. If you run out of room, you're going to have to do it in the external flash because there's a lot more of that than there is onboard flash.
Mm-hmm.
I don't know on the dev kit, I don't know how much flash there is, external flash, but it's probably relatively large.
It's also 512 megabytes.
Yeah, I think we use the same part.
Oh, okay. Is it the same part from Micron?
Yeah,
Oh, okay.
it's the same or an equivalent one. It may even be a bigger one. I don't know, because when I was sourcing parts, I was having trouble getting flash memories. And oddly enough, it was easier to get bigger ones than smaller ones. Go figure. So, you know, we may get a gig of flash instead, because it's going to be whatever I bought. And I don't know what the actual parts are. They're pin compatible. We hooked up the extra address line so we can go up to, I think, 4 gig.
Yeah, it's amazing that flash is in such a tiny package.
It is amazing.
Yeah, right now I've got the entire stack running in the onboard flash memory.
Okay. I was going to take a look to see what part I actually bought here. Flash memory is one of those things that was a pain in the neck, because the Micron ones were not available, but then Micron had some smaller geometry flashes that you could buy. And then it seems to me that was what was the company? Anyway, the company got bought out and it became like Alliance or something like that. And so the flash memories were, and I think that's the reason we actually got them, because no one else knew that these were the same parts. They changed the part numbering system. And so if you Googled enough, you could figure out what parts to buy, but it was not obvious, and they didn't cross-reference them directly. So you couldn't go to DigiKey and say, I want to buy that one. And they say, oh, well, that's gone. You got to buy this one. You had to go investigate it yourself, which is stupid, but oh well. Let's see, hold on a second here.
So Scotty, do the driver software that comes with Quartus support the flash part that you got?
It better, because it's the same manufacturer, supposed to be the same, only bigger.
Yeah, well, the reason I ask is because when you configure the part, you have to tell it exactly which flash chip you've got in the macro in order for it to run.
Right, and that sets all the parameters.
Yes, and so if there's not a drop down in the macro for the part that you have, I don't know how you configure it.
Well, that'll be interesting, since I'm guessing we're going to configure it like the old part number, even though it's not the old part number. Because these are supposedly identical parts from and I say different manufacturer, it is because all of that manufacturer's parts transitioned over to the new parts. So,
Yeah, okay, let's see. Here's some echo for some reason. What Tom mentioned, yeah, I noticed that, which it was very strange, even in the Intel Embedded Design Handbook. Even though we are using a different chip, different flash chip, they recommended to assign in the quarters to use something that not related to it at all, except for the size of the flash.
oh, okay.
Yeah.
This one is the Micron part. I believe the MT25QL512 is a QSPI part. And I'm sure that one will be in the list. Now, the part that I actually used, that will be on a different computer, because our buyer actually bought the parts that I told her to buy. So
Let's see.
and if you want to know something interesting, we were looking for another project. We were looking for a clock distribution IC, and it was by Analog Devices, and it was no stock. Samples are supposed to be available in August of this year, or in July this year. July came and they weren't available, and then you look back on the webpage and it says January of 23. So we had a project that we had built with this part, and the function it had was something that you just couldn't find anything else that would work. Now, it turns out I found, it's a 4-channel one, right? I found a 16-channel automotive version that, incidentally, oddly enough, it was actually cheaper, but it was in this huge package. It had all these extra functions that I didn't want. So I'm looking, I put in a sample request to ADI and I got an acknowledgement, but they wouldn't tell me when they're going to ship. And then I asked one of our guys, other team members, I sent him the part number of my alternate and I said, would this work? And he comes back and he says, well, why don't you just go to DigiKey and buy the part you want? Because they've got 1,000 of them. And I go, no, they don't. I checked this morning and they had 0. And I went back and there was over 900 of them sitting there. And between the time he told me about it and the time I went to buy them, about 50 of them have been sold. So I haven't been back to look. They may be sold out again by now. They got 1,000 of them with no warning whatsoever. And that happened between the morning and the afternoon in one day. So great, huh?
I'll bet they're only making automotive grade ones if they
Yeah, and
can.
you know, we found this when you can't find a commercial grade, a regulator, capacitor, resistor, go buy an automotive grade one. It's cheaper because they have more of them. I guess. I mean, I don't know why it should be cheaper, but
there's all those pickup trucks sitting out there in parking lots, you know, outside the Ford factories and stuff.
Well, I know we went out and we got automotive grade, you know, what is it, AEG something rated, whatever that standard is, and no commercial grade caps. I mean, just pick a 10 microfarad, you know, you can't, it's difficult to find them. And then you find the automotive grade ones and they got thousands of them. So it's like, okay, I'll buy a -40 to +125 C rated part to put in my on my board. That's fine if it doesn't cost any more, or sometimes it'll cost a penny more per part, like for capacitors. Sometimes it's cheaper.
I guess with the automotive grade parts, you know you're going somewhere.
Oh. No, it mostly means that you're going to break down.
So I put the Rev D board in and I can see the local temperature sensor. Should I just try plugging in the external board again?
Sure.
Yeah.
Are your jumpers set the same way?
I don't know how the jumpers are supposed to be on the new board versus the old board.
Well, if they're both Rev D, set them the same. Yeah.
No, I took out this is a Rev E and I'm
Okay.
putting in a Rev D.
Hmm.
So my external, the board out in the field is a Rev E. The local board's now a Rev D.
It should be compatible, but the jumper settings are different because they're just different.
Right.
It still should work.
It should still work.
And my one question is 18 supposed to be the local or the remote sensor? Which board is this jumpered for?
I'm thinking it's probably jumpered for the local board because I have 2 of them here, and one we have set with this one has the magnetometer chip on it.
Oh,
and
the one you plugged in doesn't.
The one I plugged in doesn't. So
oh yeah, then you should be fine.
Then it should
Yep.
be.
18
right.
sounds
The
right.
external one is holding.
If you see some smoke come out of if you see some smoke come out of my chair, you know what happened.
And you
18
are plugging
out of your
it
chair,
right
out
onto
of
the
your ears.
You're plugging it right onto the Pi, right?
Yeah.
Okay.
18 sounds right for the local.
All right. Let's see.
You know, the remotes should be one higher because they're just flipping the LSB.
Yep.
Okay, so let's see here. Share screen. Hey, look at that.
Yep.
Ooh.
Yeah.
Yeah. So.
And it's on 23.
Well, what's that out there at 1F?
Yeah, what's that?
That might be your remote temperature.
I don't think you can set it
Should
that
be
high.
remote should be at 19.
Yeah,
Well, let's also see how I have my
that may
so-
be your problem on your other board.
it worked, but hey, it worked for like, I don't know, almost a year. It worked for like 6 months and then it just quit. So it works from December 13th until June 16th, the way it was set up. So if
And
I
it was the
do
local board that the local board failed?
yeah,
Ugh.
Yeah, and that's
Well-
what I think has happened on mine too.
so
If I'm-
here's
I'm just thinking.
here's how I have run mag configured. So -M is that's the remote magnetometer. So that's 23. So that's correct. See, I had -R. I guess it's the remote temperature sensor.
Yeah, you have it as 1F. Yeah.
And so that's what I
Yeah.
had it as. So now -L, is that supposed to be the local temperature?
Yeah,
So I should
those are
probably,
funny numbers.
but now I should change that to 18.
Well, yeah,
Well, I remember when I configured this, the numbers I had here did not match the numbers that were in the manual that you gave me. And I figured these out and they worked. So
do you have some kind of address translator or something? No.
It may be the jumpers.
but you agree that I should change this
Yeah,
one
you
to an 18.
Yes.
Yes,
Okay.
you should, that shouldn't hurt anything.
And then I'll restart the system and we'll see.
Yeah,
Okay, R18 there. Save. All right, I'm gonna reboot the thing. Wish me luck. I'll let you know in a minute. But actually, if this works, I'm much happier that it's the local board and not the remote board.
yeah, it's just a little odd that you have those numbers, but be nice to know why.
Well, I do remember the 1F being an option on that board for the temperature.
you?
for the remote.
Okay.
Yeah.
So you may
Scotty
have a jumper
changed the
set on the
temperatures
remote, on the
locations.
remote board.
What's that?
So you may have a jumper set on the remote board that makes its temperature sensor 1F.
Yep.
Which is nothing particularly awful about that, but
Don't the schematics have the jumper configuration on them?
They do.
Yeah, if you look for that version, it should have it on.
I'm going to look right now for XD. Okay, let's see.
Getting a
Well, I need to go, so I'm gonna say 73.
73, Dave.
See you, Dave.
you three, Dave.
73.
7-3, Dave. I'm not long for this world either. I'm running down, but one of my magnetometers died also. So I had two units, two complete systems, and one of them never did. Scotty looked at it when we were at somewhere Dayton and suggested there might have been some corrosion in the pins or whatever, but I cleaned it very thoroughly. I never could get it running again.
I hope this isn't a
There.
recurring problem.
Here
Hey,
you go.
Jonathan,
Good.
There you go.
Jonathan, weren't you a reliability engineer?
I absolutely was, and I loved it.
We might be needing your services. But okay, I have it running again.
Looks
Do
good.
you guys use aqueous solder, aqueous flux when you
I
assemble
don't.
boards?
I don't.
I don't.
Yeah, because I know aqueous solder, the aqueous flux, you have to clean off completely because it keeps eating away at things.
Yes, that's true.
I've had boards spontaneously combust or whatever.
Yeah, they keep oxidizing. unless you clean the flux off.
Yeah, it's actually the stuff that they always told you never to use. Acid flux solder.
Acid. So if you use plumbing solder, you can rinse the board off and you're okay.
Presumably. I mean, basically the same thing. I presume it's not quite as active, but still.
But you better get it clean.
Daniel,
Yes.
Did you also reseat the board that was on there, the one that wasn't working?
No, I just took it off. So I don't know.
See, on the Rev D board, there's no way you can get 1F, but on the Rev E board you can.
Right.
Right. And Rev E is what's at the far end.
If you leave all the jumpers off, you'll get 1F.
Oh, it's working now.
Yeah, it's working right now. I'm not gonna touch it.
Yeah, take that failed board and send it back to the manufacturer.
Yeah, send it back to me.
I was going to ask the manufacturer to send me another set of spare boards along with the
Daniel, why don't you try reseating that other one first, just for curiosity's sake?
maybe later.
Yeah, not tonight. I mean, when you have time.
Yeah,
the old axiom: if it works, don't fix it. It should apply here.
Yeah, I am like way backed up with all sorts of projects.
Yeah, I know the feeling.
Right now I'm just glad it works. Yeah. So, but no, thank you for your help with that. I'm glad I'll tell you, like, I think it really does make a difference running the equipment here myself too, especially for when I have to go write reports and things like that. When you have data to actually show, it makes a big difference. So
I'm sure it does.
yeah. But that's right. This analysis toolkit that I'm working on for the grape, I think could potentially be useful for the magnetometer as well, because it's really kind of a similar sort of data, but the processing would be a little bit different, because here we're doing, you don't necessarily need to filter it the same way, but there are things that you do want to filter the magnetometer data for. So
might be interesting if you could put out the intermagnet standard for a 24-hour run.
Yeah. Yeah, I think with a little bit of adjustment, this tool could be useful for both the grape and the magnetometer.
It looks nice.
Yeah. Let me run this. Come right from the top, restart, clear all outputs. So what they started with, I've got my imports. I do some things to just set the way the plots, make the plots look a little bit nicer. And so this data inventory just goes into the directory where you have all of the data files, and then it puts them all, it parses all the file names, parses all the times, and tells you what you have. And then it will actually give you a little, Christina came up with this. It gives you a little like Gantt chart. I don't know what's, if I go back to, yeah, there it's easier to see. But there you can see like node 1 has been running since 2018 up through, I've got data up through May 24th or so. That's John Gibbons's node that's been running longest. And then the other ones have been running for about a year or so. And then we have a list of stations that are supposedly active. And so this is the total list of everybody, but the green ones are the ones that we actually have data from. And then it will plot their locations on this map, where the red ones are the ones where we actually have data from, the blue ones we don't have data from. I created this filter class So I should plot the filter response. So you can design a filter, specify what the cutoff frequencies are, and then it gives you the frequency response. And you can apply that filter to the data. So here we actually specify the node, the date time, start and end time, and the frequency. You put that all in. And then this process data, I have a couple of different processing chains that you can put the data through. So the default is what we call the standard data, which it'll compute the solar local time on the raw data. It will then resample the data with a 1 second cadence, because the grapes right now, they'll sometimes miss a second here or there. So that takes care of that. And then it'll filter it with that 3.33 minute low pass Butterworth filter that they've been using. And then finally it'll store all of the data. So throughout that whole processing chain, it will store all of the data in this grape data object. So you can show data sets. So if you hit that, it shows that you still have in memory the raw data, the resample data, and the filtered data. And it tells you information about each processing step. So if you want to go back and you want to replot any of the previous steps in the chain, you can do that. So here, just by default, it will plot the raw data like that. But you can tell it, give me both the resampled data and the filtered data on top, or let's say you want the raw data and the filtered data. So you can make sure that what you're filtering actually makes sense compared to the raw data. You can tell it to give you both of those. It's not exactly fast, but there you can now see the filtered data on top of the raw data, and you get the night day shading. And then here you can do it. You just change that one parameter X key, you change it to SLT for solar local time. And it changes it now solar mean time down here. And what's nice is this will make it really easy for working with a lot of different stations, because all of the data and the plotting methods stay with that one object when you create it up here. So it's going to be really easy to just create a for loop of all the stations you want to work with, process all of them with the exact same processing. And then you have easy access to all of the process data that's associated with those particular objects. And then here's another one. If this grape has 2 years worth of data, so it takes a little bit longer to load everything in. But then we have this another processing chain, which rebins it into 5-minute bins and takes the mean within each bin, rather than doing the 1 second resampling and applying the Butterworth filter. So this operates much quicker. And then that will let you generate these you can use that data to generate these nice plots. So this is 2 years worth of data versus solar time. And so you can see the seasonal variations and diurnal variations. And with the routines in there, you can also easily, again, flip between solar time and UTC time. And similarly, it's easy to flip and get received power instead of Doppler shift. So a lot of nice ways to work with the data.
Nathaniel, will Rachel be doing her Python experiments again with the solar flare data?
With the engineering 150 class?
Yeah.
Yes.
There is 90 days worth of SID data on 3 VLF transmitters. That could be used.
That sounds good. Yeah, we'll see how far we get with that. It's yeah, we'll have to take a look. Well, it was a lot just to get the students to do what we had them do last year in that class, because a lot of them we just had to do so much handholding because they're right out of high school and they've never seen Python before and they've never seen really heard of space weather or any of this stuff. So
And Nathaniel, if you want to do something similar for magnetometer data, talk with Hillman, but probably something like the standard intermagnet processing to produce the 1 minute samples for a 24-hour period. And then you could do things like the Tromso stacked plots rather,
right,
and a variety of other things. But and actually the processing should be substantially simpler than what you've been doing for GRAPE.
Yeah, I think it would actually be very similar. Yeah, I could talk to Hyomin, and Diego's actually been working with Hyomin, and Diego, he's been working with another code base that I wrote a while ago that actually has a somewhat similar sort of interface to it. So Diego may be pretty comfortable working on this with Hyomin.
Yeah, there's a standard filter that's used for the
intermagnet
stuff. Yeah, and that's written up in their literature, no problem.
Okay, that's great. Well, thank you very much for everyone's help with the magnetometer. I'm really glad it's working again. I think I might go to sleep.
I've got to head out too, guys.
And I see your message here, Jules, that you once said that his experience at Keasley indicated that tin-plated connector surfaces will eventually fail. So when you have some time, it'd be interesting you just replug the original local board. Okay, so you're saying that just by reseating on the 4U pin connector, it might clear things up.
Yes.
Okay.
I believe those are all tin-plated connectors, and John always said that he never trusted them for long-term use.
Interesting.
I do think we ought to try and get a sense of, because I think I have the same problem as you have. And I think we should get a sense if that's going to happen on the local end for some reason. It could be that the voltage on the Pi, I don't know, who knows? I can imagine all kinds of things, but it's just that mine was kind of like that.
Well, if you want to send them back to me, I'll see what I can figure out.
Yeah.
Send me the dead ones.
I'm not even sure I was using exactly the same.
Are we using tin connectors, not gold plated or gold flash?
Well, it's the standard connector on the Raspberry Pi.
Yeah, but you can get gold or tin.
Depending on what Raspberry Pi you get.
Well, the connector on our side, I don't remember what
the original build of 50
Pi populates with.
It was tin,
but
we've since switched to gold. Per your suggestion, by the way.
Yeah.
We did switch to gold.
We are using gold. We're not using tin.
But on the
Okay.
original D boards and E boards, what were those? Those were tin or
Those were
gold?
tin.
Yeah,
Those were
right.
tin.
That's the potential problem. But
Okay.
again, you could easily check it by a replug. If it works on replug, that was the problem.
Okay.
Because it's just the interface between the two conducting surfaces. If there's a problem, so the friction, the act of replugging basically cleans all those surfaces off again. It's like the old problems they used to have with S100 board machines. You pull them out and
Yeah.
hit them with an eraser from time to time.
It's a percussive maintenance.
Yeah.
Okay. Well, that makes sense. Yeah, I'll give that a try later and plug it back in, and maybe the same thing will work for Dave.
Make sure you break it again.
Yeah, well, that was the thing. Like, it was so hard to pull the connector off. I ended up bending some of the pins, and I had to take a little set of needle nose pliers here and bend them straight again.
Yeah.
So that's the other reason I'm not particularly enthralled with the idea of unplugging and replugging right now. Like, it works.
Well, take your time. There's no rush.
Okay. And if Dave is having the same problem, if maybe it'll work for him to just unplug it and replug it in. And
Yeah, I think I did that already, but we'll
Really?
see.
Okay.
I need to go look at it. I've just
Okay.
been obsessing over other things.
yeah.
Rev E has the gold plated, and Rev D has the tin.
I believe Rev D and Rev E both have tin, but I'm not.
Yeah.
But
The
there's
D,
a
I'm sure is tin, but I don't know about the Ds.
Yeah.
We didn't build the E's. We didn't build very many of them.
there's a new production
And
model.
and
though.
the pie itself is tin, which I
Right.
never even thought about that. I'm just so used to buying gold. Gold flash doesn't cost very much. It works fine for limited number of.
But it would seem
Insertion.
odd that you'd have this problem with one or two insertions. I mean, it would seem like if you had 20 or 30, you'd have a problem, but
No, the
Yeah,
difficulty was with time, that even with one insertion, over time, it will fail without replugging.
Yeah, tin will corrode over time,
Yeah.
especially in a moist atmosphere.
yeah, and why the inside one is failing before the outside one does. It's
Well, we don't know what environment under your
And because
desk.
the outside one's well protected.
Yeah.
Well, the outside one doesn't use the 40 pin connector. It's just using the Ethernet, the RJ45.
That's true.
Yeah, that's a good
So-
point. And those are gold.
So that's not going to fail.
Right.
unless the inside one fails, then they'll both be gone.
Right.
Inside one fails, you'll lose all three sensors.
Right. But then you just have to replace
Yeah.
or reseat the inside board.
Right.
And
Yeah,
And
so the symptoms imply that the 40 pin connector on the Pi had a problem,
mhm.
Mhm. Right.
because if it was okay, but the outside one opened up, you would
Mhm.
probably still be seeing the local temperature
Right.
sensor.
Yeah, especially since the local temperature sensor is on the local I2C bus and not on the differential side.
But again, there's no
Right.
tin connectors between the local board and the external board. It's all gold. So there's
Yep.
no reason for it to fail from that failure.
Right.
Well, the other issue is that it's quite possible that they could be getting warmer than they like sitting right above the CPU.
Mhm.
Something on that board. I don't know. That's
What's the
it
environment
shouldn't.
like under your
Yeah.
desk, kind of thing?
Except I think
Probably
that everything
warmer
that
than
we
it
have
should
on
be.
that board is would be automotive range. It probably goes to 85C.
Yeah, it should.
I keep the air conditioning going here, but it still gets warmer than you'd like it to.
And the VLF box that it's sitting on, that also gets a little warm too.
Well, as I said, thank you very much for helping me. I'm glad it works now. I think I'm going to go get some sleep.
Okay.
So
Right, 73 all.
73.
7-3.
Thanks,
See you
Scotty.
guys.
Talk to you later. Bye, everybody.
All right.